Hey guys, what's up? So in this video we'll be seeing how to create a simple HTTPS web server using C#. So let's get started with the coding part. First, let's open Visual Studio. Here I am running the Visual Studio as an administrator so that any program that I'm running or any program that I'm debugging using Visual Studio will be also running as an admin so that I don't have to worry about any security privileges as I'm dealing with the SSL things and all, and the socket creation on specific ports, anything, no restrictions because I'm running my program as an admin. It's just for avoiding unwanted hiccups during the development. I'll be choosing C Sharp, Windows Form. I'll give it the name My SSL Web Server. Now that the project is ready, I'll just start with creation of the UI. I'll need two buttons and one text box. The text box will be used for logging purpose so that I can print out any logs, debug logs, things like that here. This will be basically our server logs. And I will have two buttons. And the first button I will call it as start server button. And the second button I will name it as stop server. Okay. Once that part is done, I'll just resize it. That's it. And here in the logs, I'll go ahead and increase the font size. So that the logs are clear. That's it. Nothing else. Now let's get started with the server start. So we'll be coding the start server button first. And in the stop server button, which should be disabled by default, so nobody can press on that. And the start server button will be enabled. When we press that, we will start the server and disable the start server button, and then we will enable the stop server button. So here I'll be just declaring some static variables. Root path URL, which will be the root path of my server, which is nothing actually, D drive SSL server. So this will be the certificate path which I will be instantiating after the button is pressed. This will be for the root directory of the web server as such, that is the contents will be placed within www path. And then the main component of an HTTPS server is actually the certificate itself. So the SSL certificate, and then I'll be just creating one more variable which can be used for the locking and the thread. To be honest, it's not the way actually it should be done, but so far it's a simple thing, so I'm just going ahead and using a static variable for doing that thing. I'll tell you why we are actually using it when we go along. Then finally we'll declare a thread. First of all, what we have to understand is we are here dealing with HTTPS, that is the TLS layer, as well as the HTTP protocol as such. So HTTP has actually version 1.0, 1.1, and then 2, and currently 3. HTTP protocol, which is an application layer protocol, the version 2 and 3 is having much more complex design. For example, HTTP 3 uses, it's called Quick QUIC, and it uses something called UDP underneath the hood. So traditionally, all HTTP connections usually uses TCP. So here we will be using HTTP 1.0 or 1.1 for the sake of simplicity. And we are going to use a TCP socket for achieving the same. So first, so this is the location where the certs are going to be. This is the location where the root folders or the required folders or files of the server will be present. And we can just empty the text box in case we are rerunning it. Now we have to read the certificate before doing anything and then create an X509 certificate object, for which I'll be defining a function called getCertificate, and I'll be calling the function here. So we have to create the SSL certificate. It's very straightforward. Create from PEM file. Here you have to pass two things. One is the path for the certificate, one is the path for the key, and then we will be converting it into PFX format so that we can associate a passphrase with it. Okay. Here once inside cert directory, we have something called server.crt, which will be the certificate file, and then followed by cert path plus server.key, which will be the key file. Now once this SSL certificate is created, we can actually go ahead and create it in a PFX format. Content type.pfx, and its passphrase is going to be password. So this is actually the password that was used while generation of the certificate and the key. So when we are actually generating a private key for a certificate, a passphrase will be asked, and in my case I used the password itself. Here I'm going to use the same password. So now we have the SSL certificate object created from the certificate and the private key. So whenever we are starting a server needs to provide the certificate to the client, and the client will be giving us a challenge which has to be solved, for which we need the server key or the certificate's corresponding private key, and all the things like the challenge completion and the encryption completion, everything needs the private key, because the certificate which is provided by the server will be used for encrypting things from the client side, and things will be sent to us. The server will be using the private key to decrypt it. Then they will actually come up with a symmetric key, which then will be used for all the further communication and the data transfer, because asymmetric encryption is going to be expensive computation wise. So we will be only using asymmetric keys, that is the private key public key pair, for the initial phase. After the handshake, they both will be having a symmetric key which will be used for the data transfer. And for the time being, I'm gonna leave this exception thing as empty. If you want, we can just print out various details related to the certificate. Once we have the certificate details, I'll be adding a new line just to give this so that we can get the serial number of the certificate. Now we can actually print out the expiry date of the certificate, and also if needed some other things like not before. So now we have the basic information that we need, and then I will just put a new line afterwards and finish it off. Now whenever a incoming TCP connection comes, we need a listener to it, but everything that will be done in a thread. So we will use the thread reference that we used before and create a new thread, and inside which we will be using a TCP listener. So this is for creating a TCP socket, okay, which will be listening on a particular IP and a particular port. And here the IP is gonna be anything. Here the IP is gonna be any IP, because I'm gonna listen to any IP that comes in, IP address.any, and the port is gonna be 443 because that is the standard for SSL. Now we can start listening on incoming connections by using the start method. So in case of a browser will be actually connecting to our server multiple times. In case of a failure, there will be retries and all. So we have to keep listening. Once a client comes in, we'll be processing the client, but we won't be doing it in a different thread. Theoretically, we should be using multiple threads to handle multiple connections, or at least we should do everything asynchronously. But here, for the simplicity's sake, I'm only using one thread, and it will be listening to one connection at a time. And once a client is processed and the connection is closed, it will go for processing the next client. Okay, I'm not using multiple threads because it's gonna make it more complicated, but for the simplicity of the project, I'm keeping it a single thread. We can actually get a client from the TCP listener. Once it starts listening, we can use this accept client, which is a blocking operation, which will stay there until it actually receives an incoming client connection on 443 and the IP that we asked for. So now we need another function for processing the incoming connection, and I'll call that function prepare SSL stream. So till now we have just a barebone TCP socket established between the server and the client, and everything is plain. Every data transfer between the TCP socket is transparent and not encrypted. Now we'll start with defining this function, which will be taking the TCP client as the argument. Okay, now we can actually create an SSL stream from this particular TCP socket, which will be doing all the SSL related works for us using this TCP client. Okay, so SSL stream is equal to new SSL stream, and this constructor takes two arguments. One is the client.getStream, that is the stream from the TCP client, and then to leave the inner stream open or not, which we will be setting it to false. Once that is done, I had just before mentioned we will be using this particular is reading details complete for indicating some things. So we will be just using it here, is reading details complete. We will be setting it to false every time when this function is called with a new client. Whenever a new client is obtained, this function will be called. Then we will prepare the SSL stream. Before that, we will be setting this variable to false. Now the next part is to authenticate the SSL stream as a server. So how to do it? SSL stream dot authenticate as server, because we are the server here, and you need to provide the SSL certificate, which is nothing actually, the SSL certificate which we created or obtained from the server.cert file and the server.key file. Okay, and then we will say client certificate required, which we will be setting it to false. This you can use it to leverage MTLS, that is to provide mutual TLS, where the client also will be providing you a certificate and then you can authenticate the client based on the certificate information. But here we will be only using the certificate on the server side like a regular website. So we are just putting the client certificate required is equal to false. And enabled SSL protocols. So which all version of SSL protocols needs to be supported, like whether we are supporting TLS, SSL, TLS 1.0, 1.2, 1.3, etc. So this we will be defining it in a moment, and before that we will say check certificate revocation, which we will be setting it to false. And here we'll say SSL protocols equal to system dot security. Here one thing we have to make sure is to provide support for anything that is greater than 1.1. Almost all SSL versions are deprecated and no more supported. So we have TLS 1.0, 1.1, 1.2 and 1.3. And 1.0 and 1.1 are deprecated for most of the browsers. So here, but if you are using curl or some other small clients, they do support it. So we can say TLS 1.0 and 1.1 are deprecated. So here we will be providing support for just TLS, okay, and then we can put an or symbol and we can just copy the same and we can say TLS 1.1. This is for TLS 1.2, and if needed you can also provide support for 1.3. This is all I'm gonna support for the time being, and you can use this variable and pass it as an argument here. Okay, with this we just authenticated ourselves as the server. Now for the debugging purpose, I'll be printing out few information about the client as well as the SSL stream, for which I'll be using this begin invoke, because I wanted to log it into the text box that is an UI component and we are on a different thread. So I'm using the invoker to make changes to the UI elements from a different thread. So here method invoker, I'll just define a function here, private void display logs, which will be taking the TCP client and the SSL stream, and we'll be printing out all the necessary information into the text file. So I'll just enclose it in the try catch so that in case an error occurs, we are safe. That's it. We don't have to crash our program. And then we will be calling this function over here. So here we'll be passing the client as well as the SSL stream. And over here, obviously, we'll make the first check if client not equal to null. Sorry, if client equal to null or SSL stream, we'll just simply return. Once the displaying thing is done, so this is where this variable is reading details complete will come in handy, because as we are on different threads, when you call this function, parallelly the other thread will continue to execute, and after which it will close the SSL stream. For preventing that, we are using this particular variable before closing the SSL stream and the client connection. We'll do the implementation of this method later, but time being we'll just keep it there and we'll continue with the remaining implementation. Now we can set the read timeout as well as the write timeout to 60 seconds. That is by default the standard values. You can set it to 120 seconds or 60 seconds, that is standard timeout, or you can write custom timeouts if you are using a different client as well. So here I'm just going for 60 seconds for read timeout as well as write timeout, and then I will just wait in a while loop for the UI logging to be complete, that is this variable. I'll just put an exclamation not. So as long as this is false, this while will be infinitely waiting here without closing the stream. And now after which we can safely close stream.close, and then you can do client.close as well. You can go ahead and using in C# so that it will automatically close any disposable object, but here I'm manually closing. You can go for any method that you prefer, okay, or whichever you are convenient with. It's always safer to use using so that it will make sure the connection is always closed. And in this also, if an exception occurs, which will be happening for sure in most of the cases, like whenever a certificate is found invalid by the browser or the client that we are using like curl, we will be getting exceptions here. So I just want to print out the same. I'll be just using the same invoker so that I can update the text in the UI. Text box 1 dot text. If you want, you can print the stack trace or anything. Okay, like for example, inner exception. If it is not null, I'll get the message from that as well and print it out here. Because for some things it will say just refer the inner exception to get more info into it. So you can print out the stack trace or anything you want or whatever you prefer here. Okay, I'm just printing out these three things in case of an error or exception. I just wanted to know what happened exactly. And once we are complete, if an exception occurs or not, finally we'll be just closing everything out. SSL stream.close, client.close. And with this, we have done the implementation of how to process the SSL stream. So we are getting everything. Okay. But once we are done, we have to read the information from the SSL stream and do the necessary things like handling the HTTP protocol, responding back with the proper body. Everything has to be done here. Okay. Hope you guys enjoyed this video. Thanks for watching. Don't forget to like and subscribe. Thank you.